Hello, this is a little video I made for all Arduino fans and makers which are looking to add a little monochrome display to their microcontroller projects. Here I have a microcontroller Arduino project using an ATmega 2560, which basically emulates a little educational computer system which you can program in machine code and hex code basically over the keyboard. And for this, obviously, for the output of that little computer emulator, we were really looking for a fast reactive monochrome display, which the little not so powerful ATmega 2560 16 megahertz microcontroller Arduino would be able to drive and refresh fastly. So our first choice was the Nokia 5110, a good old classic monochrome LCD display, and this display is quite nice actually. So for example, it has background light that you can switch on and off, and in order to check its reactiveness and how fast actually the Arduino ATmega 2560 is able to drive this display, we have a little machine code program entered into the emulator, which does the following. It displays basically 6 registers on the display, and then it's basically a 6-digit counter, and obviously you want that to refresh and count display as fast as possible. So here is one mode which also shows you the mnemonics, so this is a little bit slow. So in order to really see how fast this display can be updated and how reactive it is, we go to this mode here, and there's actually a delay function built in. So the max speed of this emulator that we can achieve with the Nokia 5110 and the standard Arduino drivers for that display you can witness here. That's not too bad, and that's actually faster than the original computer model, educational computer that we are emulating here. But still, I mean, it can be a little bit laggy, especially if you, want to see, for example, the mnemonics, and you see that the display is really sometimes not very reactive in terms of refresh time. Our next choice then was that little 1.3 inch SH1106 OLED I2C or IIC display, right? And let's check out how fast this runs the same program, our counter. So if I remove the delay and enter the same screen mode, you will see that this is quite a bit slower than even the Nokia. So even though that's a very bright, nice, sharp, crisp display, also quite inexpensive, you can get that for a couple of dollars, the I2C bus is really not really fast. So we were looking for a different option. And here we have our third candidate. It's the same controller and the same display basically, still the SH1106 OLED 1.3 inch display, but this time it's a SPI version of that display, and let's see how fast this will do. Remove the delay, same screen mode, and I think you can see that we have a clear winner here. The SPI version of this display is really blazingly fast, and that's what we are going to use for our project. It's really quite a tremendous difference between SPI bus and IIC bus. I also tried playing with the bus frequencies, but I couldn't get the I2C version of that display faster. So those are the default settings for these libraries. It's using hardware IIC and hardware SPI, so no bit banging going on. And so yeah, another nice feature is of these 3 libraries, you can basically use the same Adafruit printing functions and API to drive these displays. So very few changes are required in the source code in order to drive these 3 different displays. Basically, you only need to instantiate the display object from the driver, but the rest of the source code is really identical between all 3 displays. So if you're looking for a fast little OLED or fast little monochrome display, the clear recommendation that we can give here is the SH1106 SPI version. Check it out.